Welcome back. We're in lesson 117 today. We are getting closer to the end, guys. We are almost there. Y'all are in the home stretch, and I'm very proud of you. So let's keep going and finish strong. Direct and inverse variation squared. So we talked about how things vary directly and how they vary inversely. And let's review that right quick. We say that when it is directly proportional to, or it varies directly, that our formula is going to look like this, right? It's going to, that's directly. This is directly. It varies directly, or it's directly proportional to. All right? Inversely is the inverse of that, and the inverse of that is division. So the inverse of that would equal k divided by t, okay? And that would be our formula for that. So when something varies inversely or is inversely proportionate, then we get the division problem. Now we're going to add squared to this. And all it is going to say is that something is squared. One of those variables is squared. So let me read you a couple statements so you can see what I'm talking about. The weight of a body varies inversely, so that's going to be the division, with the square of the distance to the center of the earth. So the square of the distance. Okay, so we just take distance and squared it. But it varied inversely to the square of the distance. All right, let's try another one. The distance required to stop is directly, so that's an equal, directly, it's going to be multiplication, is directly proportional to the square of the velocity. So we squared velocity, okay? Here's some more. The price of a diamond varies directly as the square of its weight. Okay? See that? All right, one more. The strength of the field is inversely, that's division, proportional to the cube of the radius. So this time it's cubed, it's not squared. So we did a 3 exponent because it's the cube of the radius. So all you're doing is you're listening for that exponent, squared, cubed, whatever it is, and you're adding that to the variable that it is in contact with, that it is mentioned with. That is all we're going to do differently from what we've already learned to proportions. Okay? Directly is multiplication, inversely is division. And when it says it's squared, you add the square to whatever that last variable is. If it says cubed, you add that 3 to whatever the last variable is. Okay? Whatever variable it says is squared, that's the one you stick it on. So let's jump into example 117.1 and see how we do. All right. The distance required for an automobile to stop is directly proportional to the square of its velocity. Ta-da. Is directly proportional, distance, velocity squared. Okay? If a car can stop in 200 meters, that's the distance, at 20 kilometers an hour, what will be the required distance for 28 kilometers an hour? So we need to find 28 km an hour. What is that? So first, we've got to find our constant, just like before. So we are going to first square the 20, right? So that's going to be 400. So k times 400. So then we divide both sides by 400. And that equals half, right? Half is k. So now we put that in. Distance equals half the velocity squared, right? Now we put in our velocity, our new velocity. So the distance equals half 28 squared, right? All right, so I need a calculator. All right, 28 times 28 is 784, okay, and we need half of that. So 784 divided by 2 is going to be 392. So the distance is 392 meters. And just for the record, what I did was 28 times 28 divided by 2. Okay, because that's 28 squared. And then you put that over 1, and it's the same as 1 times that, 2 times 1. That's how you get that in the denominator. Okay, so 117.2. That one was pretty easy. Let's see what 117.2 has in store for us. And it says, the distance a body falls varies directly as the square of the time that it falls. Okay? If it falls 144 feet in 3 seconds, how far will it fall in 10? Okay, so all we need to do is square this. So 144 equals 3 times 3, so k times 9. Divide everything by 9. All right. So k equals 16. Now we put our constant into our formula. Now we put in our time. Distance equals 16 times 10 squared. We know 10 squared is 100, so 100 times 16 equals 1600, right? And that's going to be 1600 feet because that's the dimension it gave us. Easy peasy. All right, I think we have one more. Yes, 117.3. All right, I'm going to read this and set it up for you, and I want you to solve it. So the weight, that's going to be W, weight of a body on or above the surface of the earth varies inversely, so that's division, with the square of the distance from the body to the center of the earth. Okay? If a body weighs, that's the W, 10,000 pounds at a distance of 5,000 miles, how much would it weigh 50,000 miles from the center of the earth? So 50,000 equals D. What is that? All right, so now we do the math. And we know, let's look over here. If we said 5,000 times 5,000, let's get our calculator. That's going to be 25 and 6 zeros, I think. Yeah. So 5, 1, 2, 3. Let's use our exponent key because we haven't used that yet. So exponent 2. Yeah, that's what I thought. 25 and 6 zeros. Okay, so 10,000 equals K over 1, 2, 3, 4, 5, 6. So 25 million, right? So we multiply both the top and the bottom, or we multiply this by 25 million over 1 and 25 over 1 over 1. So this cancels out. So, oh my goodness, we're going to add 5 zeros to that. So that's 25. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That equals K. Good Lord, that's a big number. 250 billion is our number here. So, let me make sure I'm right. Times. Yes. 1, 2, 3. 250 billion. All right. So now we are going to, let's just rewrite this as a scientific notation. You can see how that comes into play here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, let's stop at 10. So that'll be 25 times 10 to the 10. Right? That's what equals K. And you can do that. When you have a big number, use scientific notation so that it reduces what you have to write and what you have to calculate each time. So now let's drop that in as our constant. So our constant is going to be W equals 25 times 10 to the 10 over 50,000 squared. Now we can rewrite this as 1, 2, 3, 4. Okay, so 5 times 10 to the 4 squared. Now when we square that, it goes 5 times 10 to the 4 times 5 times 10 to the 4, right? Do you see what I'm doing? I turned this into scientific notation, and it became this, and we had to square it. So 5 times 5 is 25, and 4 plus 4 is 8. Okay, so we are going to replace this with our calculation, 25 times 10 to the 8. All right, now we're going to divide. Okay, so 25 over 25, we divide that, W equals 1. So we take our 10 to the 8 and we bring it up here, it becomes negative 8. So that becomes 1 times 10 squared. 10 times 10 is 100. 1 times 100, W equals 100. So that's 100 pounds. That's our unit of measure. All right, does everybody follow that? All we did was we changed this big number here into a scientific notation. because it would be easier to multiply and faster to multiply. And then we put it down here and squared it. Okay? So this one was a little bit convoluted, and I actually said I was going to set this up for you guys and then let you do it. And I did not, and I am so sorry. So much so that I am going to find you a practice problem, if I can. And I can. All right, so this one is from a homework that you are not going to be doing. So the number of red marbles varied inversely, so that's division, as the square of the number of blue marbles. So blue squared. When there were 4 reds, there were 20 blues. How many reds would there be if there were only 4 blues? All right, I'm going to walk away and let you solve this one. So pause, work the problem, and then unpause, and we'll see what the answer is. All right, and we're back. Through the magic of video, as I like to say, we have solved this problem. So follow along with me and see if you get what I get, or see if you got what I got, I should say. All right, so first we read the problem, and it said that the number of reds varied inversely to the square of the number of blues. So that's where we got this formula from. And then it said when there were 4 reds, there were 20 blues. So we plopped those numbers in, 4 for red and 20 for blue, and it had to be squared. So we did that. 20 times 20 is 400. So then we solved by multiplying both sides by 400, and we found out that we had 1600 K as our constant. So we rewrote our formula with our constant in place. R equals 1600 over B squared. So then it said, when there were 4 blues, how many reds? So then we dropped in 4 for B, because that's the blues. And 4 times 4 is 16. 1600 divided by 16 is 100. So that's how many reds we had when there were 4 blues. So I will see you in lesson 118.